my previous video, we did I did give you the formula for kinetic frictional force. So we are going to apply it now, yeah, with these questions. So you see, they say for each of the following, number one, draw the free body diagram without and with components where necessary for each object. So we're still going to draw free body diagram. Then number two, they say calculate the magnitude of the kinetic frictional force where necessary for each block. Okay, so let's start with number one. This box, this first scenario here, it's 5 kg block here. Remember, this 5 kg block, I'm only given, there's a, you see, remember there's a force applied, which is acting to the right. It's 60 newtons. And check your surface. Your surface says what? It's smooth or a frictionless surface, which means there's no friction acting on this object. So we can say our friction here is what? Our friction is 0. Okay, let's assume on this object which is given there. Let's assume on this object which is given. Let's assume that the direction of motion is also to the right, like this. Yeah, so that it will make sense here. Yeah, so from here, let's try to draw a free body diagram. Free body diagram, remember last time I said to make it easy, you can try to show the forces acting on the object. Yeah, let's try to label them on this diagram so that we can go and draw. We can try to draw our free body diagram. So if we try to label our forces acting on this 5 kg, remember there's what? There's always what? Weight acting on the object. It's always acting downward to the ground. So here I'm having my weight. Then we are also having what? We'll be having normal force. Remember, normal force must act perpendicular to the surface. Then you remember here it's what? That is my force applied here. It's a capital letter F. So these are the forces acting on the object. So which means my free body diagram will look like this here. I'll represent my object as a dot. So I'm going to have what? I'm going to have weight. Then here I'm going to have my normal force. Remember, these forces here, they must be equilibrium, they must balanced. Yeah, so here it's normal force here. Yeah, then here I'm having what? Force applied. So these are the forces acting on the object. And remember, there's no frictional force. So Fk itself, since it's moving, this object is moving to the right. So frictional force is what? Is 0. So this is your free body diagram. So we need also to calculate the magnitude of the kinetic frictional force. Here it's what? Our Fk here is 0. Why it's 0? Because the object is smooth. There's no friction acting on the object. So that's the thing that we must do. So our Fk for this question is what? Is equal to 0. I hope guys you did understand this. So just try to copy it, then understand like how we managed to find out our free body diagram and how also we managed to find out our Fk. So this one is number 1 and this one become number 2. Yeah, so these are answers for this question here. So I think now we can try to move on to the next diagram, the second diagram here, which is the second scenario. I'll try to rub here what I did here. I hope you are done copying. Yeah, so for the second diagram here, remember we still applying the same mass. It's 5 kg box. There's still force applied of 60 newtons, but the difference is what? Remember the difference, there's what? It's rough surface now. Yeah, it's a rough surface. Okay, so since it's a rough surface, remember there's a frictional force acting on the object. So let's try to do the first question. Let's try to label the forces acting on the object so that we can draw our free body diagram. Remember, I'm going to have what? My weight. Then there's what? A normal force. And remember here, it's your force applied. Let's assume that the direction of the motion. Remember that frictional force, it opposes the direction of the motion. It opposes the motion. You must know that. The definition for frictional force, it does not say that it opposes force applied. No, it opposes the motion. So that's the thing that we must know. But sometimes what you must know is that a force applied sometimes can be in the same direction with the frictional force. So you need to be careful, very, very careful about that. frictional force oppose the motion. You need to check the motion of the object first so that you can write your direction of the frictional force. So my frictional force here, it must act to the left. Yeah, I can write small letter f since it's moving, you can say fk, it's fine. Kinetic friction, since it's kinetic means motion. So these are your forces acting on this object. We are only have 1, 2, 3 forces acting. Fk, it's moving to the left, opposing the motion of the, and your Fk must be parallel to the surface. As you can see, your surface here, it's acting on the, your surface is horizontal. So which means the free body diagram for number 2, guys, here, I'm going to try to show it here for this number 2. So my free body diagram, it will look like this one. I'm going to draw it here. So here you show your object as a dot. So I'm going to have what? My weight, then normal h. Okay, yet normal force, weight, then yet weight. So here it's what? It's force applied. Then here I'm having my friction. Yeah, you can say Fk, it's fine, or small letter f. Remember, your symbols must be correct. Force applied, it's capital letter F. Yeah, so this one is going to be your free body diagram for this scenario number 2. Here we are dealing with scenario number 2, don't forget that. So here it's number 1. Yeah, the number 2, let's calculate our the magnitude of the kinetic frictional force on this block. So remember our formula on what is given. Remember we're given the coefficient of kinetic friction. Remember the formula, it says Fk is equal to coefficient of kinetic friction multiplied by what? Normal force. So we are going to use what? We are going to use this formula. So let me use black color here. Since we are going to use this formula here, I'm going to say what is given there. I'm given what? My coefficient of friction is 0.15. So it's 0.15 multiplied by normal force. Remember normal force from the free body diagram. Okay, from here, if you check from the free body diagram, remember, yeah, it's weight. You agree that from the free body diagram, remember when you are calculating normal force, you only consider forces which are acting on the vertical. Yeah, so which forces are acting on the vertical on my free body diagram? Remember, I'm only having normal force and weight. So which means our normal force here, the formula for normal force, remember, is going to be mg, okay, or weight. Because from the free body diagram, remember here, it will be what? Normal force is equal to the weight. I hope we are getting this, guys. From the free body diagram, upward force will be equal to the downward force. So normal force is equals to weight. And remember that normal force is weight is what? It's mg. So that is it. So which means here I'm going to say Fk is equals to coefficient of kinetic friction multiplied by mg. Your mg is going to be your mass we are given. It's 5. Then multiplied by, remember g is constant, 9.8. Then you can use your calculator here. I hope, guys, you are having your calculator. Then you calculate here your Fk. Your Fk, so it's going to be 0.15 multiplied by 5 multiplied by 9.8. Here we are going to get 7.35. 7.35. And then remember, it's what you write units. It's newtons. So this one is going to be question number 2. Okay, sorry about that. This one is going to be question number 2 for this scenario. So this is how you calculate the Fk from this given diagram. So I hope, guys, you are copying this. Yeah, and I hope you are understanding. If you're not understanding, try to rewind the video so that you understand the concept. Okay, so here I'm going to try to rub it. Okay, you can pause the video. You are free to pause so that you can try to copy the calculation. You copy the free body diagram. So I'm going to rub here so that you can do our next scenario. It's for diagram number 3. Okay, let's start. So let me try to wrap everything here. Okay, it's fine. Let's go to diagram. number 3 here, number 3 here. Check your diagram number 3. As you can see, I'm having what? There's a 5 kg block, and yeah, your force, you see, remember there's a force applied. We're still having same force applied, but it's acting at an angle of what? Of 20 degrees. So you must know how to draw a free body diagram for this scenario. So to make, okay, let me go to my whiteboard here. This one is very easy to draw because remember guys, when you're drawing a free body diagram, just draw as it is given on the diagram here. So I'm going to, okay, we are doing scenario number, let's go to my whiteboard here. Scenario number 3, we're doing question 3, diagram number 3. Okay, let's say question 3, it's fine. Okay, question 3 here. Remember, I'm going to try to draw the diagram. Here I'm having 5 kg. Then here I'm having your force here, and there's what? There's a 20 degrees here. Yeah, then remember there's a rough surface. My rough surface here, it's a rough surface. Remember, it's written, it's a rough surface. And this rough surface is having what? The coefficient. It's what? The coefficient of kinetic friction is what? 0.15. Yeah. So here you're still having 5 kg. It's a 5 kg block. Your box is still 5 kg. So let's draw our free body diagram first. That is the first. Okay, let's try to show the forces which are acting on the diagram. Remember, we're always having what? Weight here. After weight, we're having normal force. Then let's assume that our object, the direction of the motion is still to the right. Please, you must not forget that. So if direction of the motion is to the right, what I'm going to do here, remember the friction will act to the left like this. So you can say it's kinetic frictional force acting to the left, opposing the motion, and the frictional force is always parallel to the surface. Now that is these are forces acting. So which is number 1 here? Number 1, our free body diagram. And remember there's this force here. I said 60 newtons. It's force applied. You see, it's acting at an angle of 20 degrees. So I'm going to show my object as what? As a dot. Then I'll draw my weight here. Then my normal force. Then there is force applied. Then here it's what? Frictional force. That is your free body diagram. We are done from there. So remember, guys, remember, this is how you draw a free body diagram. This one it does not have components. But I don't know, for matric in South Africa, usually they encourage you, which is recommended now, to draw when you are answering this kind of question. Whenever you're drawing a free body diagram, they are no longer accepting free body diagrams with the components. But you can use a free body diagram with the components for calculations. Yeah, usually it helps. Whenever there are some components, it can help you to do your calculation to find out your F net. Okay, so we're going to do this. It's fine. As you can see here, force applied is having component here is having f of x and f of y. So you must know how to apply it anyway. Okay, so for this question, yeah, this is a free body diagram here without components, which is accepted now when you are answering your question in exam. So we are going to calculate here. Let's calculate what are we going to calculate here? We are going to calculate our FK. Yeah, FK for this scenario here. So how to calculate our FK? Okay, yeah. Let me try to rub here. I hope you are done copying here so that we can calculate our FK. But remember, to calculate our FK, as I said, we can use the one with the component. So we are doing number 2 now here. Let's find our FK. So remember, to calculate our FK, we are given the coefficient of kinetic friction is 0.15. Okay, so as you can see there, since 0.15 here, so it's going to be FK is equal to coefficient of friction multiplied by normal force. So I'm given 0.15 times normal force. Yeah, now remember guys, your normal force here for this scenario is not going to be equal to weight only. So that here you need to pay attention because it's very important. So I'm going to draw a free body diagram with components, and I said you only use this one for calculations. Yeah. So here with the one with the components, you remember we still have normal force, then weight, then I'm having what? Frictional force. Then remember this force applied is having component of what? Which is acting on the horizontal, which is we call it f of x. Then it's also have another component which will act what? In the vertical. It's f of y, which is acting in the y-axis. So can you try to copy this like this one? This one is having components. Yeah, as I said, use this one for calculations. So as you can see, to find our normal force, whenever I calculate normal force, you need to consider all the forces acting on the vertical. So the forces which are acting on the vertical here, on the given scenario, remember, we say upward force is equal to the downward force. So you see upward force is the normal force plus Fy must be equal to the downward force is what? Which is weight. But these forces, they are at equilibrium. As I said, if forces are at equilibrium, they are balanced. Upward forces are balanced with what? With downward forces. So here, this is the formula that you use to calculate what? Your normal force. So you can just make normal force the subject of the formula. Normal force here is equal to weight minus Fy. I hope you are getting this, guys. So I'm going to wrap this part here, this free body diagram with components. You are free to pause the video so that you can take your time copying the free body diagram, yeah, and so on. So what I'm going to do here, let me try to wrap here the free body so that we can try to answer this question. Yeah. So we agree that our normal force here is going to be what? Normal force plus Fy is equal to the weight. So let's calculate our normal force using the formula that I give you guys here. Okay, so from there, let me split clear. So we said normal force plus Fy is equal to the weight. So which means normal force here is equal to weight minus F of y. Yeah, I just shifted that F of y to the right. Yeah, as you can see, it will become negative. So remember, weight is what? It's mg minus Fy. You must know the formula for Fy is going to be F. From the givens, it's F sine squared. I hope you know this, guys. If it was F of x, it's F cos. Yeah, so you need to know that. So yeah, so let's calculate our number, which means our mass here we're given what? Our mass is 5 kg multiplied by g 9.8 minus force applied you're given is 60 newton sine 20 degrees. Now this one is your normal force. So you are free to use a calculator here. It's going to be 5 multiplied by 9.8 then minus 60 sine 20. Okay, yeah, we're going to get 28,478, but okay, you can round off to 2 decimal places, fine. But usually it's not recommended to round off wires to in the middle of the calculation. You are only required to round off to your final answer. So I hope guys you managed to copy here. Yeah, please, I'm still going to wrap here. So this is your normal force. So we are going to use that normal force to what? We substitute here to our formula here, 0.15 multiplied normal force. So I'm getting 28, so I'm going to wrap, guys. But you are free to pause the video. You are free to pause the video so that you can have time to copy the calculation. Okay, here. So let me wrap here. So from this step we go to, yeah, let's go back to that formula for Fk now. Since we are looking for what? Since our main aim we are looking for Fk. So which means Fk is equal to 0.15. Remember the number for that we get, I'm going to write all of it is 28,478,7914. Now using a calculator, if multiply by 0.15. Now here this way you can round off is 4, you can round off 2 decimal places, 4,27. Now this one become your Fk. That is your final answer now, which is with the kinetic frictional force for this object. So I hope guys you did understand this question. If you're not getting it, you are free to pause the video. Then you can try to, yeah, you can just try to listen to the video again until you understand the concept. Okay, so now we can go to the next question. We can go to question number 5. Okay, without wasting time, let me just draw the diagram here. You are doing question number, we did question number 3 here. Now let's go to question number 4. Okay, question 4. I'm going to draw the diagram here. Question 4, we still have the rough surface. It's a rough surface. It's 5 kg. Then the force applied is acting in this direction here, as you can see here. That is a force applied, which is 60 newtons. Yeah, here it's 60 newtons. Then here the angle here it's what is 20 degrees. Yeah, the coefficient. Yeah, let's assume that the object is moving to the right. Direction of the motion is moving to the right. Then my surface is having what? It's rough surface. Remember, it's rough surface. And I'm having my coefficient of friction is what? It's 0.15. Yeah, now, yeah, let's number first one we say we draw what? The free body diagram. Free body diagram. Yeah, how to draw the free body diagram here? Okay, remember I'm having my force applied. It's acting at an angle there, but you see that direction is fine. It's like it's moving down. So you need to draw like that also, guys, so that you don't. Now remember, there's always what? Weight moving down. Frictional force oppose the direction of the motion to the left. Then there's always normal force perpendicular to the surface. Then remember, there's this force applied. You see the way it is acting. So when you transfer to a free body diagram, okay, let's do it. Remember, it's what? It's weight here. Okay, weight, normal force, and frictional force. Remember, you see your force is like your force applied. It's acting like this, but you don't do like this. What you need to do, you need to extend your arrow there down like this. So which means here, okay, I mean it will be like this now. Yeah, now this one is your force applied. Now you try to wrap here. This one is not needed. Here, that force is on top here. Yeah. So remember, as you can see, this one will become your free body diagram for this object, guys. I hope it's clear. Okay, sorry about that. Okay, yeah, it was, yeah. Now this one will become your free body diagram. Okay, yeah, so remember, okay, let me put my weight so that you don't remember. Weight is this one, the force which is moving down. Yeah, it's weight. Yeah, weight is here, guys. Yeah, then force applied, as you can see, is that side. Yeah, so this one is your free body diagram. So please just take your time, then try to understand this one. Is very important in this scenario. Yeah, so this is your free body diagram. From here, remember, you are only allowed when you're answering this question, the one with the components is no longer accepted, but use the one with the components, guys, for the calculations. Yeah, remember this force applied is having the component of f of x and f of y, but they are going to use that one for the calculations. So I hope, guys, you are done copying your free body diagram. This is your free body diagram. Let's go to number 2, whereby we need to calculate, sorry about this, we need to calculate our let's calculate our fk. Let's calculate our kinetic frictional force, because remember it's moving. So we're looking for fk here. Yeah, we're still going to apply the same formula. Fk is equal to the coefficient of kinetic friction multiplied by the normal force. So let's do it. It's fine here. So we do number 2. Question number 2 here. It's fk is equal to coefficient of friction multiplied by normal force. So remember here, it's 0.15 multiplied by normal force. Now you must remember also for this scenario, guys, your fk here, it's not what it's not, I mean, your normal force, normal force is not weight here, because we are also having another force acting on the vertical. Yeah, so if you draw the one which is showing the components, it will look like this one. The diagram will showing the components, where we are going to have what? Weight here, then a normal force, then I'm going to have F of X like this. Yeah. Then here we're going to have F of Y. F of Y for this one, guys, remember, it will be moving down. Yeah. Like this, F of Y. You see, it's slightly different from the previous scenario. Our F of Y is moving down here. Yeah, so please, you must know this thing. It's slightly different from the previous scenario. The previous scenario, your F of Y was moving up. So you need to understand this is very important. Then I'm having my frictional force here, which is your Fk, kinetic frictional force. So this is the diagram with components. So from this diagram, to calculate our normal force, remember I said our vertical forces are at equilibrium, which means our vertical forces are balanced. So we say normal force is equal to F of Y plus weight. So that is your formula here, simple like this. Upward force is equal to the downward force. Then from there, so we can calculate. So I'm going to wrap, guys, this free body diagram with the components. I will hope, guys, we manage to copy it so that we can calculate our normal force here. So from there, our normal force here, our normal force, okay, it's this one here. Okay, I say we agree that normal force is equal to Fy plus weight. So which means, remember, Fy is what? It's F sine 20 degrees plus weight is mg, as you know, mg. So your force you are given is what? 60 newtons sine 20 plus mass is what? 5 kg times 9.8. Now we can use a calculator. What is the normal force here? Is 60 sine 20 plus 5 multiplied by 9.8. Yeah, here you get 69, 521 2086 newtons. And remember, normal force is newtons. Then we go back here. We are going to go. So we just need to substitute here to the 0.15 multiplied by the normal force. I hope it's clear, guys. Which means our Fk here. Okay, I'm going to rub here again. Okay, which means our Fk